Hi, everybody. We are looking today at the beginning of topic nine. Topic nine, and the first page of it, the first section of it, we're looking at similar polygons. All right, so we first need to know the definition of what similar polygons are. Okay, we've already talked about before. We had already talked about congruent polygons, and that's where everything was the same size and same shape. All right, all of your sides of the corresponding sides were the same length, all of the angles were the same size. Well, that is not the case when we talk about similar polygons. When we talk about similar polygons, what we have is a little bit different. We do still have corresponding angles that are congruent to each other, but instead of corresponding sides being congruent, corresponding sides are proportional to each other. Okay? Proportional to each other. That means there's a certain ratio, a certain proportion that tells us how to find that relates to corresponding sides of similar polygons. Okay? Corresponding angles with corresponding angles being congruent, what it gives us is the same shape but a different size. Okay, that's the important definition here. Okay, this is how I'm gonna. This is the terms we're going to use most of the time when we talk about similarity. Is that similar shapes will have the same shape but a different size. And the idea is like this: you've got a full size plane and a little model that's the same shape. Okay, it looks all the same. It's just a different size. It's a lot smaller scale, right? All right, so go on to this question at the bottom of your page is asking the question, are these triangles similar? So first off, that is a yes or no question, right? So that'll be the first part of it. When you see a problem like this on Canvas, the first part is going to be answering that question, yes or no. Are the two shapes similar? And what I mean by that is let's look at the information that's given to us. First off, I'm looking at the angles. Okay, we already know from this definition right here that corresponding angles in similar shapes would be congruent to each other. So I'm looking at angle A and angle D, both 50 degrees. Angle B and angle E, both 110. Angle C and angle F, both 20. Since all of those angles are congruent to each other, that I would say, yes, these triangles are similar to each other. Okay, so here's what the similarity statement would look like. Here's what the notation would look like. You would say triangle ABC is similar to triangle DEF. This little sign right here in the middle, it's like the squiggly that's on top of the congruent sign, right? But it's not, it doesn't have that equal sign underneath it. It's just the squiggly part. We would say that triangle ABC and DEF are similar to each other with that symbol right there. Now we'll also say this: the order that you write those letters matters. Okay, this is just like when we talked about corresponding parts of triangles. Okay, A and D are the ones that go together, so we list both of them first. B and E go together, they're in the middle. C and F are the last ones. Okay, you have to put corresponding parts in between your two triangles or your two shapes. You have to put the corresponding parts in the same order. So when we talk about next an extended proportion, okay, that's the next thing we talk about. What that means is that when we compare the side lengths, AB and DE, okay, AB is a length of 6, DE is a length of 3. If we put that as a proportion, okay, a proportion is just a fancy word for comparing numbers in the form of a fraction. Okay, the ratio of 6 to 3, the proportion 6 to 3 equals 2. That's 6 divided by 3. And you look at this other side that's given to us. AC, gave it a CA. CA and FD is a length of 8 and a length of 4. So that proportion is the same. It's 2. Okay, these two sides that are given to us are proportional. Okay, and you'll notice that it is the same proportion for all of the sides. Okay, that's another part of it. Okay, if we're talking about similarity, then that means the angles are congruent and the sides are proportional. Okay, so we would say that the two triangles are similar to each other. Now, in your packet, there is a blank page on the next part. That is not a mistake. We're going to come back to it. But right now, I want you to go to What is the scale factor? This page right here, it's in your notes packet. This picture shows up again. Okay, so the scale factor, at least in my mind, is exactly what it sounds like. Okay, think back to about fourth grade, fourth or fifth grade. We're going to talk a little bit of math vocabulary. Okay, when you are multiplying numbers, you take two numbers and you multiply them one times another. The answer that you get from that, the result you get, is called the product. Those two numbers that you were multiplying to start with, those are called factors. Okay? And so when we talk about a scale factor, we are talking about a number that you are multiplying times. Okay? It is a number by which you are multiplying. And when we talk about scale factor, the scale is what tells you how much you have scaled up or scaled down in size. Okay, so when we talk about a scale factor, it is the number that we multiplied to get from one side length to the other side length. So when we're going in this direction, in the direction of the arrow on top, from the smaller triangle to the larger triangle, you can tell going from 8 to 4, going from 3 to 6, we were multiplying these side lengths times 2 to get over here. That was our scale factor, was 2. If we were scaling in the other direction, we were scaling from here to here, we were cutting it in half. Okay, we're going from 6 to 3, we're going from 8 to 4. We're cutting it in half. So our scale factor is 1/2. Okay, so if we're trying to answer this question, what is the value of x, we need to see what happened to go from here to here. Okay, we were multiplying all of these sides. 8 times 1/2 gave us 4. 6 times 1/2 gave us 3. So if we're trying to find x, we would take that BC times 1/2, and it would give us this length EF. Well, that's 4 times 1/2, and that's just 2. Okay, what that means is back on this previous page where we talked about proportional sides and how we have the same proportion all the way around, that constant proportion, that ratio, is the scale factor. Okay? Those constant ratios that work for all three sides of this triangle, that is the scale factor. All right? I want to go now back to that blank page that's in the middle of your packet. That blank page is in there so that you can write these down. Okay? This right here is ways that we can tell triangles are similar to each other. Okay? And y'all will recognize a bunch of these from when we talked about congruent triangles. Okay? Side, side, side. This time, since we have a little squiggly sign in front of it, we're talking about similarity, not congruence. Okay? Side, side, side. Similarity is where you look at these two triangles and you can tell that all of these lengths are half of the corresponding lengths on the triangle on the left. Okay? From here, we got 4 and 2. We've got 6 and 3. We've got 8 and 4. Okay? All of the sides are proportional to each other. That would be side, side, side similarity. Up next, side, angle, side. Okay, you can see again, we've got proportional sides. 6 and 2, the scale factor going from here to here would be 1/3. Same thing, 9 to 3, it's a scale factor of 1/3. Or if you're going the other direction, it'd be from here to here. You would give it a scale factor of 3. Either way, you've got two proportional sides and a congruent angle in between those proportional sides. You can see A and D both have one arc on the inside of them. That makes them congruent angles. Our last one would be angle, angle. Okay, that gives us, what that tells us is if we have two congruent angles, then we've got similar triangles. Okay, I want y'all to think about this for a second. Every single triangle that's ever been created always has 180 degrees on the inside. So if you've got two angles that match each other, like A and B and D and E, angle C and F have to be the same thing because both of them, no matter how big or small those triangles are always going to add up to the same thing. Okay? So what it really is, secretly on the down low, is angle, angle, angle. And y'all probably remember this from when we talked about congruence, that this right here, angle, 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 is not enough to prove that your triangles are congruent. It only proves that the triangles are similar to each other. All right, so there's one more problem I want to show you. No, excuse me, I was wrong. That'll be all for today. Your Canvas problems, I need you to ask questions if there's anything you don't understand. And please, please have a good day.